there we go. Okay, now welcome to the December meeting. I went back all the way up to the very beginning. Welcome to the December meeting, the final meeting for 2021, and thank you all for coming. And back to what I was saying here. So do ask questions and put in links and anything that you kind of want captured for the meeting, throw them into the chat, and then we'll post that along with the video and the meeting slides. So if there's anything on any of these slides that you want to get back to, you'll be able to do that as well. Chatted with, well, I should say electronically chatted, emailed back and forth with Kevin Ross here a couple of days ago regarding their new facility. And a couple of weeks ago or so, they started moving in to a new facility. And it turns out that it's just at the south end of the same block that the old one was on. So those of you that have been there before, picture, just keep going down West Valley Highway to the other end of the block. And that this metal supermarket apparently is a place that's down right next to them down there. So it probably, from the outside, probably looked just about exactly like the old facility did. I mean, it's just basically a warehouse. It sounds like the setup is quite a bit different than what they had, though. So I'm going to meet Kevin down there sometime, hopefully in the next couple of weeks, scope out the place and see if I can figure out, if it's going to be a good fit for us. Hopefully we'll be able to make it work. So anyway, I will post details on the website regarding whether we can meet there. And, we'll just kind of, at this point, play it by ear, but hopefully we will be able to start doing in-person meetings again here soon. So the new website, I worked on it some more last night, and my son is working out the details to hosting the encoder, the old encoder content and past presentation content. And those two things are kind of static. And so what we have to have is we have to have a place where that stuff can sit. So the encoder will look just like it did before. If somebody were to feel really ambitious and want to sort of revitalize that, it could become a blog type of publication or something, and it would probably have a new look and feel. But the old archives will be available, and they'll look pretty much like they did before. So it'll just be a static HTML page with links to the articles. So anyway, we're in the process of kind of putting that together, and hopefully here in the next few weeks or maybe month or so, I'll be able to get that up so that we have that back. The plan is that when we do go back to in-person meetings, we will continue to provide this online option. So if you're not able to come to the physical meeting, you could still log in this way and work out the details of what you'll see and how you'll see it, and being able to hear people and all of that. There's some logistics that have to be figured out, but we'll work those details out. And I'll probably need some help from people that are there to make all that happen. So I'm continuing to do weekly robotics classes. Actually, we just finished here for the Christmas break, but we're currently using this this blue robot, and I'm gonna ask you guys some questions about some issues that I'm having with this particular kit. See if I get some ideas from you. So all four of these are, I should say, there's three robots here actually, because the blue one is the same kit configured in three different ways. So that's technically one robot, and then the walker is a kind of a cool thing that you can program and remotely drive. And then of course this is a basic stamp too, and then this other one is just a little line following, obstacle avoiding electric drive. And just something to throw out there to consider for if you have kids that or parents of kids that are looking for something for their kids to do. I'm kind of putting together some ideas for an online robotics type of thing, probably maybe weekly, maybe 2 times every 2 weeks. Not sure yet, but I'm it's still kind of gelling. but I'm thinking about using this kit as a basis for it, and then there would be a nominal fee. Parents would purchase the kit so their kids can have it, and then build a setup in their homes to be able to attend a Zoom meeting with me, and then be able to work on their robots. So it's an idea that I'm something separate from the SRS. It's not a SRS thing in particular, but I know we're contacted by people. I receive contacts from people on a regular basis looking for something for their kids to do. And so I was kind of thinking about, well, there's a potential business opportunity there, and it doesn't have to be anything that makes me a ton of money, but it would be nice to be able to afford to set up a nice arrangement in my office and be able to do this, and have a little bit of money for extra latte or two a month. So anyway, if you know families that are maybe looking and interested in this, have them reach out to me. I don't know if anybody, how many people saw my invitation, but I have a bunch of stuff in my room here. I'm realizing that a lot of this stuff is probably not going to get used. So I'm, and since we haven't had our physical meetings, I just sort of like to start moving it out. Now if we start up physical meetings in a month or two, then I'll just start bringing stuff there. But anyway, if anybody is in the area and wants to stop by this afternoon, you're welcome to, and you can look through the stuff I have here and see if there's anything of interest to you. And if you want to throw a couple of bucks my way, or maybe I'll just give it to you. But anyway, there is in the groups.io. There's a link, and then this is my address down in Federal Way. So I'm really close to the King County Aquatic Center, probably about a half a mile away from that. That gives you an idea of my general location. So anyway, something to consider. I am hopeful that our presenter will be here. I do not see him. He's not yet on the participant list. So I'm hoping that he hasn't forgotten. It's since he's in Istanbul, Turkey. It's 10. Let's see, 9. It's 9:15 his time right now, PM. So it's quite different time zone. But he did say he would do it, and I've had contact with him just a couple of days ago. So I'm hopeful that he will join us. Perhaps he'll join us closer to when we'll actually be starting his presentation. And
can you send a reminder email?
I did, and I just sent one out here just like 5 minutes ago, and then I talked to him via email just like 2 days ago, and he said, "Yep, I'm up for it." So anyway, hopefully he'll see all of that. Yeah. Let's see, and so let's see, presentations coming, and presentation ideas, always interested in those. We're in really good shape for the coming year. We're probably looking at the next open, I think it's either July or August, maybe an open slot, and then it's October. So most of next year is actually already booked, which is really cool. So makes my job easier, and February's meeting, I will just keep hammering on this, is going to be a special one-time mid-afternoon meeting time rather than at 10 a.m. because our presenter is coming from Japan, and 3 to 5 p.m. puts it at a reasonable time in the morning. He's actually, for him, it will be Sunday morning that he'll be coming to us from his location. So I'll continue to remind you guys of that up until it happens, and there will not be anything happening at 10. So I might just, maybe that day I might just jump on, and in case anybody does try to show up, I'll just say, hey, come on back, and at 3 p.m. this afternoon, and that's when things will actually happen. So so here's the lineup. Okay. So it looks like right now July is open. It's possible I might get, I might be able, if James is willing, I might get James Newton to do a talk about wire bots, which are the wonderful gadgets that make the amazing flying camera perspectives that you observe on football games and such possible. And they're, you know, it amazes me that they can have all those cables and wires and things flying around, and you don't actually ever see them, or rarely see them, except maybe when someone slips on the camera selection. But
Yeah, Steve,
you know, the way they can fly over the heads of the quarterback, and you know, they can get any angle perspective. And he actually has a presentation all ready to go on how those things work and amazing things that they can do. So so we might fill in July with that if he is willing. But as you can see, other than
you
that,
don't have to ask me twice, Steve. You never have to ask me twice. It's getting
okay. You're down, man. Shall I could edit the slide right here and now and put you in there.
It's getting me to shut up. That's the trick. That's the problem.
Okay.
Not
So
getting me to talk.
Are you good? Is July a good month for you?
What's the exact day in July?
Let's see. Third. Anybody right off the top of his know what third Saturday is in that month?
Is it the 16th?
That sounds like
Third Saturday in July. Yeah, I will have something ready.
All right. Look at that. So now we're booked till October. Whew. Love
you
it.
Want something for October, Steve? No, I'm just kidding, man. I'm just kidding.
All right. You're just yanking my chain here. So, okay. Now that'll be, I do actually have some other options, and I can kind of tickle the email stuff that I have. And I'm sure I can find stuff for October. And I didn't even want to think about that far ahead. It's like, okay, we haven't even started 2022 yet. Let's not like get too ahead of ourselves here. Right. Open discussions. These are really kind of fun, and I always love to. I love to host these things. I just go out and I pull stuff from the web on a particular topic, subject, and then we just open it up for you guys to banter back and forth about these things. And anybody is welcome to do that too. By the way, that's you know, it's just, I kind of use them for fillers, but it's anybody that wants to. Is welcome to you know, pick a topic, whether you know a lot about it or little about it. A lot of these things I don't know much about it, and I always learn a lot through these discussions. So appreciate that. Let's see, is Lloyd? We got anybody from Robothon committee in there? Looking. I do not see. Okay, I will. I was at the last meeting, so I will share a little bit about what we talked about. So we, the last event, which is on the 13th, the week before our last month's meeting, went well, as I understand. And so we're currently planning to do a third event, exhibition in March, April timeframe. So when I looked at the Robothon website last night, and Donna doesn't have anything open for people to sign up for that, but you could reach out to her directly and tell her that you're interested if there's a topic that you'd like to share. I need to talk to her about getting some stuff on there, because the Robothon website doesn't actually have anything on it at the moment. So not even links to the two events that we've done already, or the mini sumo competition we did back last January. So need to kind of get that going. I suppose we should talk to her about whether we want to do another one of those kinds of contests where she ran that out of her garage, just had a camera set up, and basically did a mini sumo contest online. So a couple people sent her robots, and then she just did the whole thing. And it worked okay. She could have probably used a camera person there, but it was in the early COVID days there, so she was just doing it by herself. So anyway, that's the current plan, is sometime in mid-spring to do another one of those exhibitions. And it looks like 5 or 6 people is a kind of the optimal number. Line up, then 3 people prior to a break, 3 people after the break, and it probably run from like about noon to about 2:30, 3 o'clock in the afternoon on most likely a Saturday. And after the meeting, if there's interest, we can continue just chatting about, you know, whatever things that came up during the meeting or any kind of topics of interest. I usually shut the recording off at that point, so it's just going to be just general non-recorded bantering about whatever. So so around the room, let's see here. Well, I chewed up a bit of your time there, but I have a number of things that I'd like to share myself, but I would like to open the floor to you guys first. I don't. It's not my meeting, so it's well, in a way, it kind of is, but at the same time, I love to have participation from you guys. Anybody out there have something to show, something to share, something, questions or things that they're, you know, need any kind of help with? Just go ahead and jump in. Anybody? Come on. Come on. I know there's somebody out there they've got something. I don't see. We don't have Greg on this month with his little robotic arm project. So it's yeah, I'm
Well,
sure.
I'm a new guy from South Carolina. I've got a robotic arm project that's in the background here. I don't know if you can see my screen or not.
Yeah.
I think
Okay.
I think we're on your sharing your screen.
Oh, let me let me get off of that. Let's see here. Okay. Oops. All right, now it's got to like, okay, let me, there it is. Okay. Stop sharing. Okay, there you go. Okay, now you should be able to share there, Bill.
Okay. Well, actually, I don't want to do that. Sorry, wrong thing. Anyway, I don't know if you can see my robot in the background there.
Yeah.
It's a robotic arm, 5-foot reach, 5-pound payload, ROS melodic, a couple of Xavier NXs, and I've just added voice control to it from the new Jetson voice module.
Wow.
So the spoken commands go into flex speed behaviors, and then it does pick up and find things. And it's got NVIDIA DetectNet, the downloadable stuff, and finding fiducials and runs around like that. So new guy from South Carolina.
That is really cool.
Yeah.
Well, keep us informed about your progress on that, and it's not ready for a demo at this point, right?
Oh, I've got demos. I just did a 2-hour presentation for the Nova Labs group later, but it's not. I don't want to take anything from anyone here. So probably not right.
Can I ask a couple of questions?
Yeah, sure. Yeah, sure.
Hey, listen, what's the what kind of motors are you using to drive the joints and kind of point out kind of where the motors are in the arm?
Okay, mostly they're NEMA 23 big stepper motors. They're in the transmission, which is this section here, and the heavier joints are cable driven. And it's got oh, the hand fell off. And it's got a mobile base that isn't mobile right now. Power. Hang on just a second. Okay. So am I back in?
Yeah.
Your screen is presenting again for some reason.
Yeah. I was hoping maybe I could show him, but it looks like you may. If you can you do Bill? Can you do screen sharing from your end?
I can do it, but it won't show my camera image.
No, we just
show my desktop.
If you guys just pin his video, it's fine. So that looks like it's a cable robot. Is that correct?
The first several joints are cable driven. Yes, that's correct. And they're compliant joints with series elastic joints. The ones at the very end of the wrist are the inexpensive Dynamixel motors. So they're actually one of the joints has a cycloidal drive.
Oh, nice.
Wrist. So.
Oh wait. So really big question here. I'm so excited to hear the answer to this. Actually, two questions. do you have encoders, and did you put the encoders at the joints as opposed to putting them on the motor shaft?
Yes and yes.
Oh, yes, a win! The first time that I've ever heard anybody actually, oh, that is so cool. I'm sorry, William, I didn't mean to overreact there, but like, seriously, that's the frickin' coolest thing in the entire world. That is the way to do it. Because that gives you the ability to sense torque. You can now look at the position that you've put the motor versus the position that you have a reading from the encoder, and you know how much torque is being exerted on that joint. And then you can do things like driving the motor with the torque in order to put the arm into a more compliant mode to be able to move it around and then direct it where you want it to go.
Yes, and further than that, Move It, ROS Move It, has a dynamic solver in it. So while it's executing, while I'm having it execute a Move It trajectory, I have the dynamic solver say, well, there should be X amount of torque on this joint. And then using what you're saying about the encoder versus the motor position, I say, well, now there's Y amount of torque on that joint. And I can look at the difference to see if it's within a limit or implying that it's bumped into something.
Right, and you can then choose to either minimize that torque, which will cause the arm to move with you, or you can choose to resist that torque and maintain position instead.
Precisely.
And you can choose to do the maintaining position up to a certain point and then suddenly switch over and minimize torque or regulate torque. So you can have it try to hold a position and then suddenly say, oh, nope, I can't hold the position. I'm going to get out of the way.
Yes, I'm not doing that now, but it's certainly, I could do that if I wished, yes.
Right. Everybody take notes. God, I just see so many arms that are made using exactly the same components. They have an encoder, but they put it on the motor, or they'll use some kind of drive that puts all the weight out in the arm. Now, the only thing that you're not doing in your arm is you're not counterbalancing joint 2 or joint 3, but because you're using a cable drive, you don't really have that much weight out in the arm anyway, so you don't need the counterbalancing as much as necessary. And getting the cable drive to work, that's a kind of a difficult problem in some cases. Now, did you use like a capstan type drive, or did you use pulleys, or how do you keep the cable from slipping is really the question.
It's a capstan drive, and obviously there's pulleys to go through the different joints. Okay, it needs
right. Yeah,
pulleys through that, and then it's like a capstan drive, like a windlass drive.
So there's no way that it can slip. It's going to break before it slips.
Yeah. Now there's cable stretch, of course, and other structural flexing going on. If that's what you're asking.
No, that's
no.
great. And the cable flex doesn't really matter because again, that's part of the the torque feedback. If you want really precise positioning, then you just program the unit to move the motor until the joint is at the position you wanted it, irrespective of the belt stretch. Now, it won't be stiff. You're not going to do CNC machining with it or something like that, but you can get it to an exact point within, I would assume, a centimeter or a millimeter or something.
Each joint is, again, a stepper controller, and then I have what I call minions, and they're typically Teensy 4.0 or 4.1 that controls just that joint. And then something running on the boss, on the Xavier, sends velocity commands with PID algorithms to the joints to get them to follow the Move It trajectory.
Yeah, so if you get a chance, take a look at the, well, I'll post a link for you, or in general for the Dexter robot arm, which is my day job. And your robot is, I think, the only other one I've seen that does what we're doing. We're doing the same sort of things, but we're using an FPGA to control the joints.
I've followed your work for several years, and I think you were using a Snickerdoodle. Is that the FPGA? I might have the wrong name.
No, it's a Micro Z. It's a
Micro Z. Okay.
Sync product.
Yeah, I am familiar with the Dexter and admire it. That's really cool.
Well, I really admire what you've done, actually. So we have a mutual admiration society going.
Cool. Good enough. Good enough. Okay. Well, thank you guys.
Yeah. You will need to show us doing that thing doing something for us sometime, though. We would, you know.
Okay, if people want to talk, please let me talk. I can give you just a couple things from a PowerPoint presentation with a video done if you want, or we can do that some other time. I don't mean to barge in.
You should take July. Give him July, Steve. I can do WireBot some other day.
I don't know if I can commit that far out.
Okay. Well, say, Bill, you should send me some contact info because I would love to book you to chat about this stuff.
Okay.
So you can, it's Seattle Robotics Society at Gmail. Just send me a note there, and yeah, I'd love to do that. I saw that and I'm not certain how you pronounce. Is it Can or is it Kane, or how do you pronounce your name?
It's John.
William Dalton is his name, is it not?
Oh, I'm sorry. No, Bill. I'm sorry, Bill. I've already switched. I've moved on from you guys. You know, it's like our presenter has shown up there. I see him at the bottom.
Oh, sorry, my bad.
Yeah, and I just wanted to if you just is it do you pronounce it Con?
No, it's pronounced John.
John. See, now I would never have guessed that.
Well, the C is a J in Turkish.
Thank you, John. And then is it so okay, so say your last name for me.
Altineller.
Oh my goodness. I'm gonna call you John, okay?
Yeah, okay, that's good.
I would trip over my tongue trying to say that. Okay, well, thank you for joining us, and you caught a little bit of our discussion about the robot arm there, I hope. So.
Yes, well, I will speak about two projects of mine today.
Okay.
One of them is FXIMU. The other is ROSRider.
Okay.
And I also made a show and tell station.
Cool.
So, okay.
We'll get you. We'll get you a little bit later. So.
Okay. I don't start now.
So thank you, and thank you so much for joining us too. We're.
Thank you very much for inviting me.
Yes. It's okay. So let's see. So anybody else got something that they would like to share? So let's see. There was it Adam? So Adam, you were this is your first time? Adam?
Yeah, first time joining you guys. I'm very much a newbie, so I've been interested in robotics and dabbled in some data science and stuff like that for a long time, but I've always wanted to take the jump into doing robotics. And yeah, just been trying to find some local folks to maybe team up with and maybe learn a new skill. So yeah, thanks for having me. I really appreciate it. And I'm definitely nowhere near the skill sets of some of you guys there, but I would love to maybe dabble in. I guess you guys have some kits and things like that, so would love to maybe participate in that and get to start off small, maybe.
Yeah. Okay. And you can. I mean, we can chat about any of that kind of stuff if you're looking to get something like that, or I have a lot of. I can suggest a number of things, and of course, any of these guys they can do the same thing. So.
Perfect.
Okay. Yeah. Well, welcome.
Thank you so much. Appreciate it. Thank you for having me.
Yeah. And we got anybody else that just wants to introduce themselves or just tell us a little bit about what brought you here? Okay. The silence is deafening. All right, let's see here. You know, boy, I tell you, I gotta love Zoom. Now it is not letting me switch cameras. You know, it's like it worked fine earlier, and I have a, yeah, see, I've got 3 different cameras connected to this thing, but it keeps giving me the same one. I want to just, because I really want to show you guys. Well, maybe I'll start with a couple of.
Be in demonstration mode.
Yeah, it's you know, it just always does that to me. Okay, I want to switch to let's see here. I'm gonna do a share. Okay. Let's see. So this is, what's that saying there? Oh, all right. Yeah, fine. So this is a kind of a cool little thing. Now this was this is probably from a while ago, but I believe this is a little 3D printed walking robot. Kind of works similar to the way the Boston Dynamics Spot robots walk, where it's, you know, you've got your reverse leg joints, and I believe, yeah, here we go.
Mini Pupper, inspired by Stanford Pupper, is the first open source robot dog that supports ROS navigation, SLAM, and OpenCV AI functions. As the vendor of Stanford Pupper, and we've learned a lot of lessons about how to make a robot and what functions our customers desire. Mini Pupper can use a single camera sensor to detect objects. It also supports OpenCV's official 3D camera module. You can make lots of interesting projects. Mini Pupper can map its environment and learn in real time from things around using its LiDAR and camera sensor. With the map, Mini Pupper can answer, where am I? Where am I going? You can call it self-driving technology. Mini Pupper can make robotics easier for makers, hackers, schools, homeschool families, enthusiasts, and beyond. Not limited to hopping, trotting, and running around, but can also do something different. It has everything you need to actually accomplish your mission. You will receive not only Mini Pupper hardware kit, but also additional high-quality services. It will be very convenient and helpful to let you make your own robot dog. Under the hood, Mini Pupper is based on Raspberry Pi, which means it's super expandable. We want the hackers and the makers and the students out there to take it and make the coolest projects out there. You can explore fun behaviors like jump rope and push-ups, or DIY your own use case as you want. We didn't settle for the cheapest option. We chose the right option. We wanted it to have personality and be approachable and draw people in. The servo motor is the key component to a robot dog. We've designed our own high-torque servos, which allows it to be fast and stable. Mini Pupper is built for you guys. This is the open source ROS OpenCV robot dog platform you've been waiting for. Please back our project and lay the foundation for your robot dog platform right now.
So there you go. Any comments on that?
Pretty cool. I see it's a Kickstarter. Is it just started, or has it been around for a little while? Is it still going?
Well, you know, let me see here. There's
on their page.
Videos on this same page. The meeting slides will have a link to this article. So this was published actually on the October 1st of this year. So
okay.
It may still be, you know, in development, but that looks. I'm sure if you went onto Kickstarter though and just looked up Mini Pupper, you could find it. So
yeah, I'm looking right now. I don't see a close date on it, but it looks like last they updated was November 30th. So I assume it's still going.
Yeah. So it looks like basic kit's $250, complete kit is $500. and then extra 60 to have it to get it put together. So kind of a cool little thing, though. I mean, it's yeah, love to see one of those show up at one of our meetings. So okay, and let's see, is anybody else got anything they want to share? Because if not, I can move on to another thing. This is just a little short video, and let me see here. I'll see if I can get it going, and then okay. Now I just make that big and share it. All right, here we go. About a minute and a half done. So there you go. Kind of mind-blowing stuff there. Put a pair of those 3D goggles on yet while you're flying one of those things, and then oh man, looks like fun though.
As well, I wonder how many of those they went through crash tests.
Yeah.
They have an annual contest at the IROS conference for drones flying through a maze or course, if you will. And the last one I was at was, I think, 2018. And they had, before that, they'd never had one that actually successfully cleared the course. But this one did, and it went super fast. And so after the contest, they were tuning it and having it run really fast. And there were a lot of times when it just crashed into the nets on the periphery of the course. So it was kind of fun to watch. But
wow. Oh, there we go. Huh. Yeah, it's you know, I think the it's always fun to you know, there's lots of YouTube videos on there of these drone contests and stuff, and I actually stumbled on went in someplace one time, and they were doing that in there. It was like a big, you know, a big huge room, and they had these things, and then things were flying around and stuff, and it's like, you know, they kind of buzz like insects, except of course they're just screaming. And I'm guessing that the rounds are probably pretty short with these, because what these drones at those kind of speeds, these drones can probably only fly for a couple of minutes at a time, maybe 3, 4, 5 minutes or something. So they have to have pretty short heats and then switch to different drones, and then charge the batteries and stuff in between, all that. So, or maybe just swap them out.
yeah, they usually have a bank of batteries being charged, and they just swap out the batteries.
Yeah. Okay. Oh, okay, there's that one. I'll switch to that camera. Okay. Let's see here. I'm going to get out of this one. There we go. And let me get back to here. I'm just going to show one more quick thing here. Let's see, yeah. I didn't see Randy at the Seattle Electric Vehicle Association meeting on Tuesday night, but they were up in Ballard, so they completely different location than usual, and they had some guys from Nobay who are building. It's in Estonia, and they are building a 3-wheeled electric vehicle that is pretty cool. So let me share my screen so you can see a little bit of what I saw. And you know, they have opted for a what they call a classic look for these things. You know, they're actually pretty high tech in terms of how they're built. The pickup truck is a future product. That's a prototype. They're not building them yet. But this little guy on the right here is their current model that they're coming out. They plan to start delivering these things next year. Let me see if I can. This I don't know how well you can see this. Let me see here if I can click on it. Maybe it'll make it bigger. There we go. So this is what the dashboard on one of these guys looks like, and you kind of gotta love the simplicity and the classic appearance of this thing, and that steering wheel with an actual horn ring, not spots on the console where, you know, it's got a little horn icon on there, and so you push there and then it activates a switch to make the horn go. This thing actually has a horn ring and a thin steering wheel, and you can see it's got analog gauges, and there's the one on the right or the left is a speedometer. The one on the right is a power gauge. I didn't realize it when I first looked at it there, but it doesn't go negative for regeneration. So I'm be curious to know if this thing actually does have regen. I would assume so, but don't know. The infotainment system is the best. So he says the infotainment system is like two knobs, a volume knob and a selector. So it's like, what do you want to listen to and how loud do you want it? That's the infotainment system, you know. And I had the opportunity to meet the CEO. He and several of his coworkers were at the meeting, and got to talk with him one-on-one. It was really fun. Very interesting fellow, Roman. I don't remember his last name. It's probably in here someplace. There he is. He says he wanted to build a vehicle that was fun to drive and not distracted by all the technology. He says, you know, you go to so many cars now, you know, Tesla's kind of set they've sort of set a direction, or a general direction that a lot of other EVs are following, which is, you know, you got that big screen in the middle of the console. The dashboard is very plain and blank except for that screen. And he says, well, people sit in front of computers, they're playing with their phones all the time. And he wanted to build a car that is fun to drive and is not distracting with all this technology in it. So the car itself is just, he says this car is just, it's just fun to drive. And it's like, okay, I really want to drive one of these, to try one of these guys out. And they will be coming to the United States next year, and they're going to start in the West Coast. So somewhere on the West Coast here, they'll come in and they'll be doing demo rides and drives with these things. So I'm looking forward to that. I'll just play this. I don't know if I'll play the whole thing here, but I'll just play a little bit of this video. He's talking about what he calls the carbon tub, which is this is a single it's a single joined piece of carbon fiber that protects the passengers. And so this is where you sit inside this thing, and it's designed after the same technology that race cars use to protect drivers. There's sometimes you watch these races and the cars get into these horrendous crashes, and this piece of the car will sit there and it'll tumble down the road, and when it stops, the guy climbs out of it, and other than being kind of disoriented, he's fine because this thing is very strong and protects him. And so they've modeled this inside their car.
Hi, my name is Roman Muller. I'm the CEO of Nova Cars USA. We get a lot of phone calls and emails from people asking, how safe is your car, Roman? How safe is Nova? Let me tell you, we're very excited. We have signed UK-based company FAR to design carbon chassis for Nova. What you see left to me right now here is our first draft based on the drawings, calculations made by FAR. Carbon is tough. Carbon will save your life. You probably have seen those horrific crashes at the motorsport events when the car flies to the pieces, but the centerpiece stays intact. It's called carbon tough. A lot of time, driver just climbs out of it and is safe. Carbon is also extremely light. Alex, let's see. Not bad. This carbon chassis weighs 4 times less than our original tubular chassis that were built for the first 2 cars. Carbon will also last. There's no fatigue. That's why it's highly used in aerospace and the space industries. You say carbon is expensive. Yes, it is. But we believe with the serious production and keeping Nova chassis very simple, we can get to the point when Nova is affordable for all of you. Thank you.
So they are their cars are going to run around 40K. So they're kind of at the nominal, nothing, not extraordinarily cheap, but not extraordinarily expensive, and they are they weigh about half as much as a Nissan Leaf. So they're coming in at about 2,000 pounds for the car, as opposed to close to 4. My car with a 62 kilowatt battery is almost 4,000 pounds. And let me see. I wonder if I can, I will indulge me for a second here. I want to find they have actually, I'm going to do that one. And my Nobe, if this is I'm pretty sure this is the site that has the, they brought these, oh yeah, here we go. Okay, I'll let you just kind of enjoy this for a moment. So Roman is actually driving this vehicle, and he says he talked a little bit about what it was like driving it in the snow like that. And he says the thing just handled amazing. And, here it is just kind of driving down the road, and that's him there on the right. And very interesting, the kind of a boat tail design on this thing. People were pretty excited after they took this thing for a ride, and he says it has a very you tend to feel very close to the environment you're driving in with it. I don't know if she comes with it or not, but that would be kind of cool. So anyway, there you go. Any thoughts or comments on that?
That's pretty cool, Steve. Thanks for sharing. Curious, did you have any feedback about, I guess, the purpose or how it handles with the 3 wheels? Like what the purpose of the design of that was? I'm sure
You know,
it's very intentional.
it turns out, well, actually, it turns out that the reason that motorcycles like that are actually pretty popular nowadays, and you can go and the trike design, and then, of course, it's obviously there's two kinds of trike design. One is it's like a motorcycle with a big rear end on the double wheel. Or you've got the ones that look, from the front that almost looks like a four-wheeled vehicle until you kind of go around the side and you realize that there's only one wheel in the back end.
Mm-hmm.
There was actually...
Yeah, it's called reverse trike configuration.
Yes. And let me see here. Let me find, there is let's see, Nobe EV versus Reliant Robin. So the Reliant Robin is a vehicle that if you've ever watched the old Mr. Bean episodes on TV, you've seen the Reliant Robin in action, and you know that has got to be one of the most horrifically unstable cars out there. It's a really let's see here if they've got I'm trying to find a kind of a short video for you here. This one's sorry.
Yeah, James is saying wheel in front is a really bad idea. One in the back is okay if the car is front wheel drive. Okay.
Right, and theirs is front wheel drive, and they've moved the battery into a pretty good spot toward the front so that it's
I'm not a huge fan of three-wheel cars. Even if you do have front wheel drive and the two wheels in front, the one in the back, you lose. You're in one of two cases. Either you lose a bunch of cargo space because you have to taper the body to the one wheel in the back, or you end up scraping the left rear and left right sides if you go over an uneven surface, like if you turn the wrong way going down a ramp out of a driveway or a parking structure or something like that. You're going to hit one of those two corners. It's not worth the extra hassle from what I've seen, and whenever I see that I always kind of go eek. Another one that does that, and by the way, this is being recorded, isn't it? So I have to be very careful what I say. If you look at the Aptera electric vehicle, research very, very carefully that company's history before you invest. I think I can get away with saying that.
Okay. It's interesting speaking about Aptera. I was, after I saw this stuff on Tuesday night, and I went looking at that car in particular, and I found a Jay Leno's Garage episode from a decade ago about that car, and I realized that car has been out there sort of in development for an awfully long time.
And the trick there is that it's the same people, it's the same car, but it's not the same company legally. Ask yourself why that might be.
Interesting.
So did they say how many or what the range is on a bucket full of electrons?
On the Aptera?
No, on this car.
One.
This one, the Nobe, about 160 miles with a 21 kilowatt battery. So that's comparing that to a Leaf with a 40 kilowatt battery, one of the new ones, can go about 150-ish miles with twice the size of battery. So it's a 800 kilogram, 2,000 pound vehicle. Yeah, it is what it is. I mean, it's not a huge vehicle, but it's, it might be suitable, for some folks out there. I mean, it's not going to be the answer to everybody's, hey, this is the EV that everybody should buy. Well, they may believe that, but it's going to have its own.
Hey, Steve, two quick points. One of them is it's 11 o'clock, and the second one is that's an awesome video that you have queued up.
Yeah, I was, it's if you. you know, and that's a good point. In fact, I'm not going to play this, but if you see the title up there, "Rolling a Reliant Robin," this is like one of the classic episodes about this car. And
maybe you can post the link in the chat.
Yeah, it's pretty fun. Okay, I will do that. So yeah, let's as a matter of fact, let's go ahead and roll into a break, because I want to get our presenter going here. And so yeah, I will do that. In fact, okay, I'm not sharing anymore. Good. One quick thing before we move into the break, and I'm just going to try to make this very brief. Okay. So let me see here if I can get this up where you guys can kind of see what I've got here. So this is those kits, those kits that I do, robots with the kids. This is, let's see, let me, why don't you, let's see, just pin me to your, to the video, and then that'll full screen my, my camera to you. And this particular configuration is designed to use these single piece rubber treads. Well, what I discovered, I was working with some kids here just this week, and when we put this tread on this thing, these three wheels on each side that suspend the tread, there's no spring tensioner in here. These are hard mounted directly to the frame. So there's just there's spacers between these gear type wheels, and so you kind of stretch this thing onto the three, and it turns out that the darn motors couldn't drive it. And it was kind of frustrating the kids, because as soon as they would connect and try to drive the thing forward, it would surge a little bit, and then it would stop, and then it would disconnect, and it was like, yeah, this is weird. And multiple times they did that, and I says, you know, that looks like the microprocessor is rebooting. And so I put a meter on the battery and then watched as they did it. And sure enough, the battery voltage went from 9 volts down to about 5 volts. And then it would pop back up to 9 volts when they let off on it. And it was like, and so I took the tread off and just put rubber tires on the back gear so they could drive this thing around. But my question is does anybody have any suggestions of what I can do about this rubber tread to maybe make it work better?
Well, you can. I had the similar problem, not with the exact equipment, but what happens is the rubber thread locks it in with force, so the motor cannot move. And when the motor cannot move, it draws too much current or something electronic happens that will reboot it. But what you can do is to either use a vise to make the thread larger, or change the wheel diameters to give it a little slack, so it's too tight.
Yeah.
You can also use a hair driving machine, like you pull, and with the hair driving machine you can heat it up, so it's easier. I had the same problem with the Tamiya ones, that when I was using a 3D printed body for it, but it's basically also, it points out, I mean, like when your motors are forced, or like if someone takes, like a kid takes it and turns it with hand, if it reboots the processor, it means that there is a problem with the motor driver. And the way to avoid that is to feed the motor driver, to feed your microcontroller with a diode. And after the diode, you put a cap, like an electrolytic cap. So if there's a power surge, that your microcontroller power supply will not crash. It can happen when it's overpowered, or if it crashes. That's a common problem in robotics.
And having the same battery that runs the electronics as runs the motors Yeah, is a potential issue, and I've run into that with other robots before. It's better if you can power the microprocessor completely separately, because okay.
Well, a Schottky diode and an electrolytic capacitor is what I do.
So if I were to take a hair dryer and heat this thing up, should I like stretch it and then warm it up with the hair dryer?
Yes.
Yeah. Yes. Okay. I will give that a try and see if I can do that, and then I'll see if I can possibly reposition these wheels a little bit too to maybe give me a little bit more slack. It looks like I might. There's holes. It looks like I could move about 1/4 of an inch. I could move these rear drive wheels about 1/4 of an inch forward, which would maybe it might make it too loose though. So I'll have to experiment with that. But there's yeah.
Could you try, I don't know how your wheels are mounted, but could you try using the small wheels on the motor? Maybe swap a big wheel for a small wheel so that you ended up with one of the small gear teeth motors at the back.
That's an interesting thought. I'll have to try that and see if that works. I don't know. It might.
Yeah, I don't know how your wheels, what they have for hubs.
Yeah, see the rear wheels, the mounting for the rear wheels is different than the fronts. The fronts actually have a let's see here. The fronts have these just bolts going in. This back one it's a small bolt compared to the other two. So I think that the threads on the drive shaft of the motor are tiny compared to these guys. So it may, I don't know if it might be interchangeable like that. I mean, this is just putting the kit together per the instructions, so I'll have to try that out. Okay, well, I will play around with that a little bit. So I do appreciate the suggestions, and I would like to let's see. I'm going to just go here, get that back down, and I'm gonna. Okay, I'll have to. Okay, I'll leave that up here, and let's see. I'm gonna jump. Well, maybe I'll just really quick go back to sharing my screen here for just a sec, because I need to get to our break and get to our presenter here. Just a quick info. These are a couple of the club kits that we have available. You can email me at the Seattle Robotics link if you're interested in these guys, and be happy to share with you about them and give you information. We have two different ones: the Parallax propeller chip base that lets you do it's essentially multitasking, 8-core processor, and then the Arduino Uno based. And so these kits are available through the club. Let's see here.
We'll definitely be contacting you about that, Steve.
Okay, sounds good. Yeah, this Adam, right?
Yes.
Yeah. Okay, I will be looking for that. I'm just realizing that why is it not letting me go any farther here? Oh, okay. I switched to the wrong. Sorry about that. I switched to my different presentation there. Okay. Let's see. Roll on to the next one. Just a quick. You guys probably already know this. Same link as next month as this month, and just general information here. And I will be we will be starting Jean in a little bit here. I'm going to roll into. So I've got a clock up there, and I'm thinking I need to run to the restroom myself. I'm thinking about, let's see, we've got 11:11, almost 11:12. Let's make it 11. Let's see. I don't know. Does 8 minutes seem too long? I'm thinking not 11, maybe 11:17 or 11, but let's say 11:17. So let's call it 5 minutes from now. So 11:17. Let's reconvene, and then we'll get our presenter started. Sound good? I'll take that as a yes. All right. So, John, why don't you go ahead and if you want to share your screen and just put your first slide up there, that'll be
Okay.
And we'll just
Oh, well, I can select cameras, but how do I? Okay, there's a big share screen.
yeah.
Okay. And
There we go. Okay.
And they make that share screen button a different color so that you'll see it really easily, which always makes me not see it because I filter out anything that's not one of the colors of the other button.
Yeah. Okay.
oh,
Stop. Okay. I'm going to go ahead and let's see here. Chat. All right, so there's the video for rolling the Reliant Robin that Top Gear did. So anybody that's interested in that. And
hey, Ken, are you you're just sharing, I think, one terminal window. So
oh, okay.
I mean, I'm not sure about that, but it looks like that's what's
Yes.
happening. So you may want to not
correct?
share and then share the
Okay.
entire screen instead of sharing just one window.
Yeah, that's probably.
Should I select whiteboard or?
Usually, let's see. What are you running? Are you running on a PC?
Yes, I'm on Ubuntu and.
Oh, Ubuntu. Anybody?
Okay, I see. Yes, that one. Okay.
That's the right
go.
one. There you go. Yeah,
Okay.
I mentioned that because I've done exactly this multiple
Thank you
times
very
on
much.
presentations and then
Yes.
wondered why I couldn't see the.
Yeah. Okay, I'm going to. I got about 4 minutes here. I'm going to run to the restroom really quick, and then I will be right back.
Okay.
And Okay. I think we are about ready to go.
Okay. So I start.
Give me just a second here.
Okay.
So as I said before, I will admit that my tongue is way too lazy to properly pronounce your last name. So I'm just going to call you John. Okay. And thank you so much for coming for us. You were suggested to me by a guy that is always out there looking for presenters and sent this information. And I didn't even realize until after we had chatted via email that you were actually in Turkey. So you're coming to us from quite late in the evening there, as I figured.
Yes.
But we appreciate your accommodating us, and we always love to hear from all around the world. And since we started doing online meetings, we've been able to do this like never before. You know, we've had presenters from all over the place, and it's really fun. So I'm really glad we have this opportunity to hear what you have to share with us. And with that, I will go ahead and let you start.
Okay, it's very nice joining you tonight. I have two presentations. It will be really quick. Okay, I developed this motor control card called ROSRider. So it's basically you plug it in using USB, and it turns any encoder motor, and I mean any within 2.5 amps range. It turns any encoder motor into a precision current feedback servo, and it has monitoring for battery voltage, current monitoring. It can drive serial LEDs, and it has an auxiliary power supply. ROSRider is an accessibility project which aims to make people build ROS-compatible robots at a lower cost. The second project is FXIMU. It's an inertial measurement unit that provides orientation, linear acceleration, angular speed, and magnetic field in 3 dimensions. FXIMU is based on ROSRimu tools. It uses the complementary IMU filter of the ROSRimu tools package, which I am sure many of you use. So it is the same code, except that it runs on embedded microcontroller, which is an ARM Cortex M4. It's a TIVA-C, that TM4C1223, made by Texas Instruments, and running embeddedly, I mean, running this filter embedded provides lower latency, which is critical when you're driving a robot, because even like 10 milliseconds, 20 milliseconds latency causes, I'm not saying could cause, it causes, because the first time I was experimenting with this, I was running the filter in Raspberry Pi, and because of latency, it caused problems. I only produced like 12, maybe 14, and all of them have been sent to people that uses them in real applications, and the feedback has been very good. They said it's a high fidelity IMU. FXIMU has auto gyro bias and axial gain determination, which you can find in more expensive setups, and it's really useful. And I developed the original ROS filter code. Furthermore, the gyro bias and axial gain determination didn't work in all cases in the original code because of some reason, and I experimented with it and made sure that it works in all cases. And all the configuration parameters can be determined by ROS param using a YAML file. or it can be recorded to EEPROM of the model. Calibration tools and instructions and scripts are provided, so you can calibrate it without taking it out of your robot. That's sometimes a problem. So when the IMU is connected to the ROS, you have to unmount it and calibrate it and put it back. So I made it sure. I wrote some programs which are available in the package, in the FXIMU package, where you can make a bridge and feed any calibration program with this bridge. Once the FXIMU is, once you have the calibration values, you can record it to EEPROM, and all the units come factory calibrated. I mean, I calibrate them, calibrate them before shipping them out. However, after, if it's mounted on a metal robot, it has to be recalibrated. So here is the parameter file. Actually, I will show you the, okay, first I will explain this. Here is where you put acceleration gain and magnetometer gain. This bias alpha is for auto tuning. You can read it up to 400 Hertz. I mean, the sensors work at maximum 400 Hertz, and you have an output rate driver, which can be 2, 4. So you can make your measurement, let's say at 400 Hertz, and then use an output rate driver of 8. And that will provide you 50 Hertz data, which will be further filtered. So because in the 8 times that the measurement is done, the filter converges to ground truth, and then it's outputted to ROS. You can select adaptive gain, bias estimation. This GFSR is the sensitivity of the gyro. 0 is for 2000 DPS, 1 is for 1000 DPS, and so on. And this AFSR is the accelerometer sensitivity. World frame 0 or 1 determines if it's ENU or NVU, which is useful when you're using ROS packages like robot localization. It requires ENE data, and it's a pain to convert them. So the device does it. I added as a feature to the device, so you can easily select 0 and 1 to make it NVU or ENE. You can turn off the magnetometer if you're in a magnetically noisy indoor environment. You can turn off the magnetometer and just use the gyro and the accelerometer. And you can also change the IMU frame ID and the magnetometer frame ID. These were the configuration parameters, and these are the calibration parameters. These first 4 determine steady state detection. So the IMU self-calibrates itself when it's on a steady state. So when the robot is stationary, all the data coming in is a noise, so it averages them and determines the gyro bias, which is very important for orientation finding. It also adjusts the gain of the accelerometer. This is hard iron settings, hard iron offsets, and these are soft iron calibration parameters. And finally, these are the initial gyro biases. So this is how the unit looks like. I will show you in a second as it's working. And these are the code repositories. This is the only package you need to run FXIMU. This is the source code for the firmware. And these are the Eagle files and Gerber files if you want to build it on your own. So this is a completely open source project. And now I will open my, okay, I will stop screen sharing and I will go to the other camera.
Do you say, John, just for a sec, do you have your chat open? Can you see questions as if people pop them in there?
Yes.
Okay, there was a question about whether you're using ROS or ROS2.
Okay, I am using ROS, but I'm also writing the firmware for ROS2.
Okay.
But I haven't actually decided how to do that yet. I obviously don't want to use a ROS bridge, I mean the ROS2 bridge. Maybe I will just put my embedded code and write a client. Or maybe I will port micro, there's this micro ROS toolkit, and it has to be basically ported to TM, to the TVC microcontroller. But for both my boards, I'm actively working on ROS2 compatibility.
Okay.
Okay.
Thank you.
So this is the FXIMU, and I will. Oh, I cannot do both screen sharing and. Can I do both screen sharing and camera? I think not.
Yeah, probably not. Yeah, so you probably just need to switch to your.
Okay, I will.
Other screen. So we've
So
seen
you
what's
see,
going on.
this green light is going on. The green light means it's in a steady state. So you basically put some thresholds for the gyro, for delta gyro and accelerometer, and when it's within these thresholds, it's accepted in a stationary state. When I move it, as you see, it's only going red. Red means it's connected to ROS. Right now it's connected to ROS. Can you see it? The unit?
A little fuzzy there. It's probably a little
fuzzy. Okay, it's a autofocus camera. I don't know how to.
Oh yeah.
So I will show from now. I will share my screen.
Yeah, I just share the screen and those. You can move it around. Tell us what you're doing, and then we should be able to. Yeah.
And here is the RVS, and I am moving it around.
Cool.
So it's really, I mean, you have to feel it to play with it. It's really high fidelity, and I've been working long time and experimenting long time on it. Indoor navigation is kind of problematic. But yeah, if you have your device calibrated for the environment, it does work. So, and even if you don't have magnetic input, it still works, and you can. Yes.
Can you hold it under your share camera there, because we can see your video and your screen share at the same time, but it looks like you've moved it away. Yeah, okay, there we go. So now we can see, as you move it, we can see the screen update. The only thing you have to do is you just have to pin his video.
Okay. Okay. Can you see it now?
Yeah.
Yeah.
Okay.
Yeah. Thank you.
Okay, so. And I did test this on number of robots, and by the way, it works flawlessly with all ROS packages like robot localization, ETF localization, because there's this issue of covariances. I don't know if any of you run into it, but if all those robot localization and extended Kalman filtering packages require the data to be in correct format, and it requires the covariances to be set correctly. So yes, I spent some effort on that to make it work, and I have some videos on YouTube of the actual robot in the ROSRider channel, and where here I will now show you. Okay, this is a software package available under FXIMU. This is just a simulation under Gazebo with the IMU. I mean, for the YouTube video, but it works with the actual robot. Here is the green line is the IMU data fused with encoder data, and the red line is just the encoder data. So the robot, what it does is it just goes to goal points, you know, goal point A and B. It just paces between goal points. And as you can see, the green, I mean, it's not that great, but it still keeps point A and B. And of course, there is this, here is a video of the real robot. This is a 3D printed robot that I made that works with my boards. And now I will show you the other board, which is these. Okay, now I am closing my RVs and putting a stop to that. So, yes. Can you see my camera?
Yes.
Okay. So this is the ROSRider board. It's an accessibility project, but it does have many features. And one thing I hate when building robots is building cables. So I made it in such a way you can use standard cables that you can purchase from AliExpress. Okay, for example, these are the new, I don't know if any of you work with the blue ones, but they're really nice, the DG01 encoder motors. And they are like $5 for 2 of them. So you just plug it in like this, and also it uses these module battery connectors, right? So you just plug in the module battery, and then also from here you plug it to USB. It is an RTC. It can self-turn off and self-turn on. And it does keep track of time, which is important in many applications. So I built a number of them over time. This one. Well, and the latest one. Okay, so I guess this is the latest one, but it hasn't been mounted yet. It's kind of smaller, thinner. The board was made in OSH Park at United States. And so also the copper thickness is twice more. All the semiconductors, like the microcontroller, motor drivers, other current measurement, and the auxiliary power unit is made by Texas Instruments. So I just use Texas Instruments silicon for this. And okay, here is another example robot. So basically, this is a Duckytown chassis that I designed with the 3D printer. This uses Pololo N20 motors. I don't know if any of you like to use these motors, but they're really small and nifty. And so this has the JST-SH connectors. So again, I use readily made cables to connect it, because one thing is that when I build robots, I really don't, I mean, if the cables are neatly organized, and it has to be accessible. So if you fix something, you don't have to pick it apart. You can also use it with these kind of motors. They are surplus motors from electric, robot vacuum cleaners. You can like really get them for $10, $20 each. And it's a really cheap alternative. And one thing that with the encoder motors, there's bipolar or B-phase encoders, and the cheaper ones use single-phase encoders, right? I also made the software configurable so you can use it. With the cheaper motors. Now I will move to my presentation about ROSRider.
Okay.
Okay, let's turn off RVs and this thing. Where is my presentation? I got excited and okay. Can you see the presentation?
We can.
Okay. So I've already said the things inside the presentation while talking to you, but this says features. And so any motor, any gear reduction rate, any encoder motor can be used. You give these parameters in a YAML file, such as the gear ratio, the PPR, wheel diameter, and the PID constants. And it just works, for any two-wheeled planar robot within the current range of 2.5 amps, it will just works. Also, the encoder reading is done with hardware quadrature encoder interface. I took steps to make signal conditioning to furthermore accommodate to use any cheap encoder motor, and I have basically bought all the hobby grade encoder motors and tested if it works. So the hardware, usually if you program this kind of thing before, you use interrupts to read the encoder signals. But I mean, you can use interrupts to read encoder signals, but if someone changes the parameters, puts in a different motors or a more precision encoder, you almost always have to recode the thing because it occupies your main loop. This hardware quadrature encoder interface is built into the Texas Instruments microcontroller, and what it does is it takes this encoder signals and it has custom hardware like a CMOS counter that basically does the counting. So you don't have to make your main loop. You don't have to cut your main loop. So during start, ROSRider takes all these parameters and listens on CMD well and publishes odometry. It also publishes diagnostic messages such as battery voltage, consumed current, motor left current feedback. The motor drivers is a Texas Instruments DRV8801. I really like them. So it gives the current feedbacks and status messages, and it also has software fuse, which can be triggered by under voltage, over current, or motor over current, and can be configured with ROS param. This is like a safety feature because I want kids to play with this. So if like a kid puts the finger in the wheel, it will stop. Also, in small motors where the microcontroller is used to control motors, EMF and transient voltages are problem. When the robot bumps into something, or if the wheel is turned externally, it will create transient voltages on the system. All these problems are solved in this board using transient voltage suppliers, voltage limiters, and polyfuse elements. It also has hardware fuse, just like since many of us use LiPo batteries, it has hardware fuse that checks three conditions. It also has a polyfuse, and it will immediately shut off the system if something goes wrong. So this is kind of an early version. The ones you've seen started from EE. Right now I'm at G. And the final version is X, but so I will explain. These are the motor connectors, the RTC battery. I've been trying to do this RTC integration of the real-time clock into a robot board for a long time. So, you know, maybe if you can make it, you know, wake up in the morning, check certain conditions, and then go back to sleep. It has I2C serial and an SPI port, a USB connector. It also has hobby style I2C connector. So if you're familiar with Arduino Pilot, many people have sensors that go with Arduino Pilot and that are I2C. So you can use this kind of connector sensor, like Arduino Pilot style sensors with this board. It has a serial LED driver. So if you're making a robot with lights, like the Duckytown robot, you can have the LEDs, 3 LEDs in the front, 2 LEDs in the back. And it has the sleep button. It can sleep, wake up by pressing the buttons. And it also has a, I mean, in this picture, there isn't one. There is a question here. What's the part description? Okay, it's an XT30, and it's found on all the model planes, all the RC cars use this connector. I put it there specifically so you can use a hobby level battery, but also if you don't like it, you can remove it and you can use a clemence, a standard clemence. It will fit right in. So it has a special footprint that will accommodate both the, I don't know, maybe I'm using the wrong word. In Turkish and in German, it's clemence, but it's this blue things where you put the cable and you use a screwdriver from the top to fit the cable.
We call it a terminal block.
Terminal block. Okay, so it will also accommodate a terminal block.
Okay.
And it also, the final version has an auxiliary power supply where you can switch on and off 5 volts, 500 milliamps. It's useful for turning on and off a fan because, I mean, if you're using with the RPI4, we now need cooling for our robots. So these are the hardware specifications. This is the microcontroller. It's a TIVA-C, 2 motor drivers up to 2.5 amps with current feedback. Well, it's 6 to 15 volts. I say it can go higher than 15 volts, but I put the software fuse condition at 15 volts. It has driver for serial LEDs, I2C, SPI, and serial ports. It can hibernate, wake up, and it can also wake up an external host computer such as RPI4. This real-time clock, hibernating, waking the thing, I put a great deal of effort into it. Also, it has auto sleep. if it's not connected to ROS, the device goes to hibernate. It has this onboard RTC, and it has a MOSFET power switching, right? So it can disconnect the battery with MOSFETs. What happens if you don't do this is if you have leakage current and a LiPo battery, I mean, even if your microcontroller is in a sleep state, even if you're like leaking microamps, and if you forget the robot, it will destroy the battery, right? So I had to put this MOSFET switch. Battery voltage and current monitoring is done with INA 219, also Texas Instruments. There is the hardware Polyfuse. Oh, by the way, the serial is a virtual serial port, and it can go up to 1 megabit. So it's really nice too. This the Texas Instruments chip has a USB host controller. You can do special things with it. You can even make it a MIDI controller. So basically, the difference between regular serial connection is, I mean, the regular selection serial connection will go up to 230,000 too, but because of noise, you will get data errors. But this USB CDC serial developed by Texas Instruments really does go up to 1 megabit speed total, and it doesn't get affected by noise. The auxiliary 500 milliamp power supply can be switched on and off by software by issuing a ROS service call, basically. It can be controlled with serial 2 or I2C. It uses standard JST connectors and commodity JST cables. This is one thing that I spent also some time on, because making cables is a real pain, as you all know, and you can buy packs of 50 JST cables for a couple of bucks on the internet. So this is an example setup. We have the Raspberry Pi here. It's connected to the FXIMU and the ROSRider board with an RC battery, and it has a YD leader, a cheap leader, and a battery pack. So with this setup, you can use it, maybe make a small robot, or maybe make something like a Roomba or a Nito size robot using commodity hardware. It can also run all the other people's ROS code, like a Turtlebot tree. All the Turtlebot tree code runs on it. Okay. With LIDAR attached, it can run SLAM. With LIDAR and IMU, it can also do cartographer. With LIDAR, with addition of a fisheye camera, it can do visual lane following, or with a little change in MIT DuckyTown software, you can use the DuckyTown stack too. Without LiDAR, but with FXIMU, it can run the robot localization ROS package and has configuration and visualization files for testing. With no sensors, LiDAR or fisheye camera, it can be used to teach ROS, odometry, these kind of things. It can be utilized for building small educational robots, self-driving cars, small rovers, observer and sentinel robots. It can be also cascaded. It can be also used as a, like if you want to do an antenna tracking device, you can use it. Okay, so I have two firmwares. One of them is you just send CMD well and it broadcasts odometry data. The first one. The second one is ROSRider Simple. It provides a control effort listener and broadcasts position and velocity per motor. This simple, well, the first I wanted to make an integrated system, but then I figured out that having just the control effort listener makes it more configurable. So it facilitates implementability of position, velocity of effort control interfaces as a ROS control package. The PID and odometry is calculated on ROS computer on the host computer, where on the ROSRider firmware, PID is odometry is calculated on the board and sent to the host computer. The first firmware is easy plug and play, only requires ROS serial and ROS parent server. Both versions can control LEDs, and it can broadcast ROSRider diagnostic messages. And I also made packages for differential drive controller, odometer broadcaster, and goal controller. They are both available to use with ROSRider Simple and ROSRider firmware. Both have initial pause listeners where you can use the RVIS to transparently set initial condition and goal. It can operate at 10, 20, or 50 hertz. The firmware can be updated with using XTS 110. Also, I made a special header connectors. So people who only have a Tiva C launchpad, I mean, many people have this, it's like $12, where the XTS 110 is like $100. You can use the Tiva C board to update the firmware. A tool chain is available to compile and upload the code to ROSRider with Catkin tools. Here is the ROS packages. The firmware is not open source yet. After I sell the first batch, I will open source it too, and I can also share any part of code with you if you like. It has a gazebo model. It has an RVIS URDF. It has a goal controller. Well, these are not really related with the ROSRider projects, but they're open source packages that I made. It has trajectory following from coordinate file, Hall transfer based visual lane following, ball following, pacing between two coordinates. Also, there is a ground truth package where you can use a ceiling mounted PS3 camera. I don't know if you guys are familiar with it, but you can use this ceiling mounted camera and what do they call it? Aruko tracker, like a tracker. So it will give you exact position of the robot, so you can see if your localization package and Kalman filtering really work. Also, all this can run on Raspberry Pi 4, and I tried both Docker and LXC configurations. I don't know if any of you run ROS on the Raspberry Pi 4, but because of certain reasons, it doesn't really run nice. You need Docker or LXC, and these are kind of pain in the ass at the beginning, but after a while, you get used to it. And I provided documentation how to use. By the way, with Ubuntu, the latest version of Ubuntu, with LXC, it works great. And it runs on 64 bits. So yes, here are the configuration parameters. This is the update rate. This is where you determine the encoder PPR. This is the gear ratio. This is the wheel diameter, base width, the distance between two wheels. This is the main amp limit. So these are the software fuses. What will happen is if it passes over 8 amp, it will disable itself. This is the motor amp limit. This is the battery volts high, battery volts low, max maximum RPM, and these are the PID parameters for the motors. PID parameters can be also dynamically configured, which is a great feature when it makes it easier to tune. So ROS2, I have a ROS2 plan. I'm waiting for the micro ROS guys to port it in TM4C 1, 2, 3. But also I feel this micro ROS, I mean, getting the entire ROS stack on the embedded, I don't know if it adds complexity. Okay. So micro ROS is already ported to TNC, which is same class of microcontroller. And the micro ROS team has confirmed that it can run on TM. On the TIVA C, they did offer documentation and help. Okay, this is from this blue robot. This is a map of my house that was done with cartographer. Well, now I will open the, okay, this is the FXIMU terminal. I want to also, I hope it works. I rehearsed all this, but I didn't rehearse this part. So,
Gotta love a live demo.
yes, I hope it doesn't flame.
Oh, come on. That would just make for an entertaining show.
Okay, not for me. Okay. So you can see my screen?
So we're seeing
the terminal, right?
You're seeing your terminal screen, and then on your camera, we're seeing the blue robot.
Okay, so okay, so well, this was a problem with the early boards. It won't start without the RTC battery. So I determined it would be difficult for user if they don't have the RTC battery. In the new version, this was a bug. It didn't start without RTC battery, right? So now you see the LED on. Okay, more than the
bug in ROS code. Say it
What?
isn't so. I said you found a bug in the ROS code. Say it isn't so.
No, it's not in the it's not in the ROS code. It's in my software. Okay, it's in my hardware. Actually, the new one. So here it started and it connected. It has a system control interface. It has a LED service. It has a, so I will go on to another window in a while, but okay, it has left wheel state. It has state position. State is basically velocity, but these are names given so it will work with ROS packages. And it has diagnostics. It has a publisher for diagnostics. And it has subscribers for control effort where you give PW, which you basically give the PWM. So these print the parameters, update rate, PPR, encoder PPR, gear ratio, wheel diameter, base width, amp limits. You can, oh, by the way, because while setting up robots, you can maybe mess up cables. The motors could be of different specs, so you can swap left and right encoders. You can set the motors in reverse polarity. This encoder AB means if it's using, if it's true, if it's using A and B as phase. If it's false, it's just using A, which enables using of the cheaper robots, cheaper encoders, which are not bipolar. Okay, so you can determine the dead zones. It has a max idle timeout. I better make it work before it turns itself off. And it also has this RTC clock. I will just go on another terminal and I will make a gross topic list. So this is the diagnostic packet, I'm sorry, this is the diagnostics topic. Let's look at this diagnostics data. Oh, pardon me. Okay. So basically, you see the left current bus voltage, which is kind of low right now. It has number of flags where you can debug everything from configuration, power, and motor status, and system status. And you can use these to debug, but there's also a simpler way. If the driver is disabled, false, so it's good to go. And the DT is the loop time, right? It changes. So you can use it to debug. It's really useful so you don't have to unmount anything from your robot. And let's make a ROS topic list again. So this is the ROSRider simple firmware. It has control effort, position, and state, basically. I will okay, let's give it a PVM of 300 out of 1000. By the way, it's 12 bits, and you will see the motor working. What happens is you saw the motor, the robot make a slight turn. It also has the security feature where you have to repetitively send these commands every 100 milliseconds. I mean, not every 100 milliseconds, but 2 DT times. So if your loop speed is 10 hertz, the command you give will expire in 0.2 seconds. This is a security feature. If your code is buggy, so your robot, or if your Raspberry Pi crashes, so it won't crash into the wall. So what you have to do is, if we give repeat R20, it will, just continues to work. Well, you see it like this. I stopped it. Let's also show you the position data, and I will turn with my hand and you will see the numbers moving. Okay, you see?
Mm-hmm.
So, and it has also this ROS service. Okay, there's a LED emitter where you can, I don't have a LED board right to me right now, but so basically you can program 5 LEDs, whatever color you want and whatever blink hertz. So just like in a car, when you turn on the indicator to turn left or right, you don't have to send messages every time. You just give the frequency and it does automatically. So this provides, I'm trying to conserve the bandwidth between the board and the host controller. So you can okay, let's call the LED emitter interface. And so basically front left, top, front right, back left. These are LEDs and the frequency. So you can issue this command and it will itself, gives serial LED commands, and you don't have to do anything else. You don't have to, to turn on and off the light. You send different signals. And let's look at the okay, so this has simple, just one command, which is a number, but I will go to the documentation. And show you what kind of commands are available. Okay, so these are the commands that you can use both to debug the robot. It has a soft reset. Basically, if the software fuse is activated, you have to issue a soft reset. It basically resets the variables and parameters without resetting the board. You can request a hard reset, and you can reset an encoder reset, or send it to hibernate. The Texas Instruments DRV 8801 has many settings. It has mode 1, mode 2. So basically what it does is, the mode 2 means when the PWM signal is at off phase, it connects the terminals of the motor together, like for braking. So it's useful when you're making a precision servo. Okay, this is a Texas Instruments feature, but you basically issue these commands to system control interface to make it mode 1, mode 2. You can also on the fly reverse the motors or turn on and off motors, or the auxiliary power control interface can be activated by this. And you can also write all parameters to EEPROM by sending 81. I added, since this documentation was written, I added a few more commands. There is command 90, which will basically take the ROS time and synchronize the RTC with it. It's not that great. I mean, there is like a 0.1 second delay or something like that. You can also print the RTC time with command 81 and 91. So here in this documentation, I really explain in detail how to do ETF, filtered odometry using these or any other things. And well, I still have to work on the documentation, but so basically out of the box, it works with the ROS localization package. And that's about it in my presentation. Do you have any questions?
Yeah, so I always find it really difficult to get going with the Raspberry Pi, just the amount of like linear meet time that it takes to compile everything from source and download everything and get it all set up is just too much of a pain for me. Are you going to provide a Raspberry Pi 4 image or some?
Yes, I will provide. Yes. Yes, I also spent lots of time doing that. It has to be Raspberry Pi because really, like, people cannot afford those expensive Jetson boards. And with Raspberry Pi 4, we got the user space library problem. I will explain you what is going on because of intercompany problems, not releasing documentation and these kind of things. Raspberry Pi 4 doesn't work great with ROS, right? But the latest Ubuntu version, it does work. It has a everybody wants a 64-bit user space library, right? The latest version of Ubuntu on Raspberry Pi 4 works great, works 64-bit. The user space library is 64-bit. And there's also the problem with camera. I mean, if you get all these working on a Raspberry Pi 4, you won't have the CSI camera enabled. So with the latest version of Ubuntu on Raspberry Pi 4 and LXC, which comes default, okay, and if you have all these working on Raspberry Pi 4, then you can't get ROS 4 running. So the latest version of Ubuntu comes with LXC, and it does work great with ROS. Okay, with ROS 1.
What is it? What are you saying that it comes with Alexi? What is that?
Okay, LXC is a Linux containers. It's like right now, you know what Docker is, right?
The container service, so you can drop things in place easily.
Okay,
Okay, yeah, I got it.
Painful to set Docker, but LXC comes default in Ubuntu now. I mean, if you're running Ubuntu, you have a container manager called LXC, and Ubuntu has provided great documentation how to run ROS with LXC. So
okay,
all
so
Ubuntu people.
What happens then when you get all of everything's up and running 64-bit, Ubuntu, latest Ubuntu on Raspberry 4, you've got your containers installed, and then you want to use something that requires a 32-bit environment? Are you out of luck, or is there a way to do that as well?
Well, for example, what 32-bit? Because
well, if you're going to ask me for details, yeah, I was just thinking about times in the past on other projects where I've run into that, where there's some piece of software that I needed that required the old 32-bit libraries. But in this case, I guess
well, I have pushed all the things into 64 bits. I mean, the camera, the serial connection, the CSI camera, and the user space library. But yes, of course, if you have 32-bit requirement, you can open another container, but it will be kind of slow, you know, like to have two containers. Sure. Okay, sure, but yeah. So basically I have 64. I have pushed everything to 64 bits. I have the camera working in user space with user space library with LXC. One minor problem with LXC is that, you know, you have all these things in a container and you kind of have problem with communicating with an external container, but that is solved too by using, okay, you had to put on your Raspberry Pi a USB Wi-Fi adapter. The default Wi-Fi adapter will not allow Docker or LXC or any containerization system to be contacted from outside. Okay, so there is this Edimax. It's an American company. They make this great little Wi-Fi adapters, which can be opened in I don't know what mode they call it, but the Raspberry Pi 4, the native Wi-Fi on RPI 4 doesn't support that API call. So if you're running with a container, and if your robot has to be contacted from outside, you would need a different Wi-Fi adapter than the Raspberry Pi's built-in one. Maybe, I mean, I would have to prepare much more with the LXC, but I can show you guys maybe in another session how to do the LXC with Raspberry Pi 4 and the common problems that people face.
Maybe like a setup video or a web page that walks you through the whole, like, you know, start with a blank Pi 4.
I guess I will have to provide documentation how to do that. I haven't done it yet.
All developers want to develop and not provide documentation. That's all of us. Yeah, I got you.
Okay. So yeah, I told everything that I wanted to tell you.
Okay. Well, thank you very much, John.
Okay.
Can you switch your camera back to you? We're still looking at your workspace there.
Okay, I will. Yes.
There we go.
I
Oh,
have
and
one more
also,
question. What's that circle
this,
behind you, that track on the wall? What is that?
Oh,
it's a 3D printed wall frame that goes. There is a video of it on Vimeo if you want to watch. There's also on my webpage.
It's a magnetic train that goes sideways on the track. That's too
Yes,
cool.
that's right. There's a video of it too. And,
I love that. That's great.
yeah, I can turn it on. And it's, oh, wow. It's four-wheel drive too.
Oh, I love it. And so it'll actually run around the track and stay on the wall because of the magnets holding it down?
Yes, yes. Well, you know, the magnets are hidden and these are toy train tracks. But if you put it on a flat metal surface, it really works like you cannot. It works as an illusion, you know. Like now I have the wooden panel, and you can see that there are metal, and you can guess that it has magnets. But magnets alone don't do it. You see these wheels are shaped like V, and it has this rubber band. So I cut slingshot rubber, and I put with pliers. I put the slingshot rubber onto this wheel. What happens is when it's compressed, it causes traction. But it's more like a demo. I don't think it has any real world use because it spends a lot of energy. I mean, with that kind of watts that's making it go around, I can make it fly, you know. Oh, and also one more thing. This project has been supported by Turkish National Science Foundation. So I have a small desk in an incubator, and yeah, they have been helpful in providing feedback, but basically I'm operating out of my own money, developing this, and all this FXIMU, and I mean the ROSRider will be because of chip shortage crisis, we had some problems, but it's almost ready to be produced in mass, and I will be selling it on Tinde for little or no profit, basically.
Oh,
Wow. That's
Thank you
nice.
very much.
Looking forward to it.
yeah.
Thank you very much.
Yes, thank you. Thank you, John.
Okay.
Any more parting questions here for our presenter before we let him go to bed? Unless he's one of those guys that works through the night.
No, I have been really preparing. Like I made here a setup, a show and tell station, 2 cameras. I have lights on my face, which are hot. I made a little station here, and I do have to sleep because I'm tired.
Yeah. Well, it's also about 11:20 your time there, I think, right?
Yes, it's 11:20.
Yeah. So, all right. Well, thank you so much for sharing with us.
Thank you for inviting me.
Best wishes on your success for your business and in your projects.
Thank you.
Yes.
Okay. Bye.
All right. You can, if you want to sign off, you're welcome to do that, and we will continue on our end here a little bit. All right.
Thanks, John. Nice to meet you.
Yes. All right. So let's see. I'm going to, let's see, I'm going to go ahead and stop recording here. I think we're pretty well done. Let me just check my slides here. So yeah, I think I already covered all of that. So yeah, so anyway, thank you all for attending the meeting. If you want to hang out and chat about anything that we that came up during the meeting, or have anything else that you want to share, I'll stay here for a while, although it's like lunchtime. So And I know Adam wanted to talk about kits, so happy to continue that conversation. So anyway, I'll go ahead and